Hi, this is part 4 of the NuTone NM100 Intercom Master Station repair, and if you haven't watched parts 1 through 3, I suggest that you do. As you would have seen if you have watched part 1, one of the problems that we discovered with this NM100 equipment that the customer sent in to us was that his transformer is dead. There's no voltage output, and all of the testing and repair work that was done on the NM100 Master Station itself was done using a shop transformer that I own. So this is a NuTone model NA300TA transformer, and it's the same transformer that's used on the DMC1 and DMC3-4 and also the NM200. They all use the same transformer. And this transformer has no voltage output at all, and I suspect that there are fuses inside the transformer and the fuses have blown, and that's why there's no output. So this video is going to be about repairing the fuses in the transformer. I haven't done one of these before. We do have another NuTone transformer, the 801Ts, that we open up and replace the transformers in. And in some respects, this one might be somewhat simpler because it's not all encased in a steel enclosure. The windings and everything here are under the blue tape, which is already exposed. So that should make it a little bit easier. And the first step is that we're going to take the transformer off the mounting plate here so that we can get that out of the way. I don't think we'll be able to remove it completely because the wires go through, and I'm not going to take the wires out of the Molex connector on the end because that's just not necessary, I think. We'll get our little parts cup there, and we'll go ahead and take these 4 screws out first. I'm not sure why the trend in putting fuses inside the transformer, I'm not sure when that started or why someone thought that was a good idea. I'm sure it doesn't have anything to do with the fact that if you blow the fuses, most people couldn't replace them themselves, and then you'd have to buy a new transformer. I don't think that was probably the motivation behind it. Even though on earlier, because this is essentially a music and sound design, and what's unusual, if you go back to music and sound systems back in the 80s and 90s and probably even early 2000s, there was a fuse holder on its mounting plate, depending on what style of transformer mounting plate you had, but there was a fuse holder on there, and you could simply open it up and pop out the fuse and put in a new one, and you were good to go. So building it into the transformer thing is kind of different, but that still seems to be the way that they do that. So we'll go ahead and we'll look at this side first, and I think I can actually see down inside here probably where the fuse is going to be. So I think the first step is to cut open the blue tape and see what we've got underneath it. I haven't done one of these before, so you get to see me figure it out as we go along. The transformer is a dual output transformer. The black and white wires here, these are the 110 volts or 115 volts in, so that's the primary side, and then there are 2 output. The blue and red wires are 16.5 volts AC at 39 volt amps or watts, and then the brown and the yellow are the other output, and they're the same voltage. So this side perhaps is more the primary, but what we'll do here is we'll score this. What I expect to kind of find under this, if it's like other transformers that I've taken apart before, is under the blue tape will probably be some kind of cardboard insulator or something like that, which there is. And then see if we can get the blue tape to stay down. Let me get something else. Put a little couple pieces of blue masking tape to keep the other blue tape out of the way. And then looks like the cardboard insulator is held on with some yellow tape. Take that off. We have to save all this because we really do have to put this all back together like it was, and we'll go ahead and score that a little bit, see what we have. Now I don't see anything that looks like a fuse right off the bat here. This yellow tape is probably some type of heat resistant tape like Kapton tape or something like that, which we have here at the shop. because transformers do tend to get kind of warm when they operate, and if you don't have heat resistant tape, if you were to use, say, like vinyl electrical tape or something like that, there's a fuse. So it's actually fused on the input here. So what we have, which I think you can see, let me move this around. So on the white wire here, the white wire goes through the plastic bobbin right here, and it fits in one of these slots. And then the end is stripped off, and then underneath the yellow tape, move that out of the way, it's soldered onto a little glass fuse that's right here. So let's take a look and see if our glass fuse is any good. We'll just use our multimeter on continuity, listen for the beep. So if the fuse is good, it's not blown, we should have continuity through the fuse. And we don't. If we touch the same end together, it's good, but if we touch one end and the other, I'm putting it on the soldered wired ends and on the body of the fuse, and not getting any continuity there at all. So let's go ahead and take the fuse out and see what we get. So a good way to do this, you have to be careful when you do this because you don't want to destroy anything. There's not a lot of extra lead or anything like that in here. So turn the soldering iron on, give it a second to heat up. The soldering iron we're using today is a Heiko FX 951, which is a really good soldering iron. So unless your budget is really tight, I highly recommend buying one. That's as long as it takes to heat up. It's about 4 seconds, which is great. So a good way to do this is you can add a little solder to the joint to start with. Get this one bent up off the plastic here, off the tape. You add a little bit. Lots of times modern electronics, you've got lead-free solder, which is all great and swell, but hard to beat the actual leaded stuff, especially when you're desoldering. So if you add a little bit, it'll mix in with whatever the factory solder is, and then you can use your solder braid and soak it up, and it's just twisted together so it's not too hard to get off. There's one side, and we'll do this side. And see if we can get the fuse wire. The input lead wire is stranded wire, and the fuse lead is a piece of solid wire. So they come apart pretty well. And this is how you do a fuse-ectomy. Oh, there it is. We dropped it on the floor. 5-second rule, doesn't matter. There's our fuse right there. So I'm going to peer at this real quick and tell you what it is. See if it says. After carefully looking at the fuse, I actually have to take it and look under the microscope to read the rating on the fuse. So for those of you who don't know, most fuses stamped into one of the metal ends of the fuse will be the amperage rating and the voltage rating. Now, most common fuses used in electronics or appliances or anything like that, they're all going to be rated for 250 volts, which is normal. And then this one apparently is rated at 1.5 amps. And I had to scrape away, there was this sort of goopy, clear coating, varnishy kind of stuff, which is probably a byproduct of the manufacturing of the transformer, and it was kind of obscuring the letters or the numbers that were stamped into the end. So I cleaned it off without scratching it up too much and looked at it under the microscope, and it looked like I said 1.5 amps, and then I did a quick calculation for the input fuse rating for a transformer of this size, and 1.5 seems about right. Probably could have been 2 amps, would have been okay too, but we're not going to modify it because this is what it was UL rated for or in this case it says it's ETL rated, which is really the same thing. It's not proper for us to change from what they said. So I found a replacement for it, which is this one. It's the same rating, same size. It's something I had in one of my parts bins, and it is new. What I'm going to do with this is I'm going to install this in place of the one that was blown. This is a glass body fuse. The body, this clear part right here, is glass, and I prefer the ones with the ceramic bodies because they're a little bit sturdier. General purpose fuses come in two different sort of styles, many different sizes. That's not relevant to what we're doing. But there are fast blow fuses and there are slow blow fuses. The idea behind it is the instant that they're overloaded, the fuse blows and it shuts off the device. Slow blow fuses are a little bit more forgiving. You get maybe 3 or 4 seconds of overload before the fuse blows. And slow blow fuses are more commonly used in, say, audio amplifiers, because sometimes when you're running an audio amplifier, especially if you're running a high powered one and you're running it at loud volume, there can be times that you get these really brief power surges that the amplifier is drawing a lot more current through the line fuse. And if you have a fast blow fuse, you're going to be popping fuses every time that happens. So they'll put a slow blow fuse in because it gives you a little bit more of a margin of tolerance. You can have those really short bursts of increased current and it's not going to pop the fuse. And I have a feeling that the reason this fella's transformer has a dead fuse in it is because one of the common things that we've noticed after having installed a lot of NM series intercoms, and it would be same for DMC intercoms, is installers have a bad habit of wiring up the transformer to house power. The house power is turned on so the transformer is live, and then they take their multi-pin plug here and they plug it into the Intercom Master Station with the transformer being live. Now, the installation instructions specifically recommend against doing that, and I believe what's happening is the current surge of plugging the intercom into the transformer while it's live, it overloads the fuse for just an instant and it pops the fuse and the transformer goes dead. You're not supposed to plug in the intercom on a live transformer, but the reality is that's something that a lot of people are going to do, and I have a feeling that may be what happened with this one. So I think putting a slow blow fuse in is a better choice because you're sort of guarding against people's inclination to do things the way they normally do them, and I don't really think a slow blow fuse is going to compromise the integrity of the design of the transformer. So I think it's a reasonable thing to do. So we're going to be ordering in a whole bunch of these. Smallest size, the larger size would fit, but it's a little tight, so we'll go with the smaller size like they use with a ceramic body in a slow blow configuration to give ourselves a little bit more of a margin for error. So let's go ahead and install this. Try to do this so you can actually see it and keep my big hands out of the way. The easiest way to do this is to sort of match up what was done before, which was it was just sort of twisted together on the copper wire that are the windings of the transformer first. So if you get one side twisted like that, the best thing to do is solder this side first, because that's going to help hold the whole thing in place. When you bend it around to twist the other side. Since the lead is kind of long, we'll clip off the extra because we don't really need any extra in here. And then we'll sort of bend it around some, making sure we keep it away from, you want to keep all of this side isolated from this side. And we'll do more of that after we get it soldered together. So now we'll twist the fuse lead around the white primary lead like that. Should be fine. And we'll solder this side like that. We'll clip off the extra. we'll make sure that our white wire is down in the slot in the bobbin, and we'll sort of push it all down in place. Now, we need to cover this up because the yellow tape, which was covering it up before, doesn't really have much in the way of adhesive left on it. So this is where our Captain tape comes into play. Captain tape is a high temperature Scotch tape, as it were, and it's designed for electronics or any kind of higher heat application. It actually will withstand up to, I think this particular roll I have here, over 700 degrees Celsius or 700 degrees Fahrenheit, and it won't melt or shrink, which is really what you want. So we'll put a bunch on here like this, and then we'll also restore this side. If you think that you can just get by with, plain old Scotch tape, you're going to be surprised, because that doesn't work very well. Scotch tape, as soon as it gets hot, it's going to melt and fall apart. So we'll start like that, and then we have some wider stuff. Same kind, just a different width. I'll cut a piece of this. That over here. We're going to trim off the excess that's running on the ends, or fold it back over itself. The most important thing here is to get it well covered and keep it all in one place. That should be good. And then what we have to do is we have to put our piece of cardboard back. And then we have to take our blue tape that was on the outside. We'll take our blue masking tape off, because that doesn't really belong there. And this is going to go like this, but I think it would be good to put some Captain tape to hold the cardboard in place, since the cardboard is sort of what's covering it all up and protecting it. And it may not be cardboard, it may be some kind of fire resistant cardboard. They don't usually put flammable things inside transformers, so it's the mysterious world of transformers. So that should be good like that. Now we'll be a little neater with our tape. The seam back together. The blue tape. That. We'll try to get it so it looks halfway neat, like that. That. And one more, just for good measure. All right. So that should be pretty good, I have a feeling. Now, the question is there a fuse on this side, and is that side blown or not? And I think the way we can check that is by doing a continuity check on the low voltage output when it's powered off. So let me set that up. So the way you can check, I don't know if there's any fuses on the output. I have a feeling there's not, because if there was, there would have been a second fuse on this side fusing the output of one leg of the secondary side into either the red or blue wire. So I have a feeling the only fuse is on the input here. The easy way to check that is the way this is constructed. The blue wire goes into the windings of the secondary side, and they go round and round and round and round and round, and then they come back, it comes back out on the red side. So if you use your meter on continuity mode, again, listen for the beep. If you had a fuse on the output and the fuse was blown, there would be no continuity. There would be a break in the circuit. So if there is no fuse, or if the fuse is good, and you measure between the red and the blue, and you measure between the brown and the yellow, and you have continuity, then you know that either there is no fuse and it's fine, or there's a blown fuse and you need to replace it. So we'll just plug it into, we'll just test it here in the plug-in. We'll do blue and red, and it beeps, and we'll do brown and yellow. So that's okay. So we have continuity on both of the secondary outputs of the transformer. So I have a feeling that there are no fuses on the secondary outputs. The only fuse is on the input. So now the next step is to verify that we've solved the problem and the transformer is good. Let's power it up and see what we have. So I've got the transformer wired up on my bench power supply. The bench power supply is set to, it's an AC power supply. It's set to 114.5 volts, which is fine. We'll flip on the switch. Let's see if we have any sparks or flames. No, apparently not. And we'll measure our outputs, and so it's blue and red, and we've got 17.1 volts, and brown and yellow 17.1 volts. So you probably want to see that, so let me move the camera and show you. Okay, so here's our line voltage going into the transformer. We've got 117, that's a little high. Let's turn that down just a tad. 114, that's fine. So we'll do blue and red, 16.9, and yellow and brown, 16.9. So they're both the same, they're both equal. Now our transformer is alive, so all we have to do is put it back together. So our NuTone model NA300TA, which is also the same as a Music and Sound TE5D. It actually says here, I didn't notice it before, it actually says here model number TE5D on the label, and that's a Music and Sound number, so that sort of helps reinforce the idea that they're for the same models. It's all put back together. We know it's good now. We replace the input fuse on the primary side of the transformer, and it's alive again. So that's good. That's how you fix the blown fuse on a NuTone NM series or Music and Sound DMC series low voltage transformer. I hope you found this interesting and perhaps helpful. If you did, please give it a big thumbs up on YouTube, because that always helps. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell or on the wheel, put in your email address, and every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.